Thank you everyone for joining us for What's New with Amazon EC2. It's always great being back in Las Vegas for reInvent. Just love this week as we have a ton of innovative announcements. It's great to talk to customers. My name is Martin Yip. I lead Amazon EC2 and networking services. I'm joined by...
Hi, I'm Art Battle. I'm a Principal Product Marketing Manager. I'm excited to be here today to talk to you about some of the latest innovations that we have in Amazon EC2. Martin?
Yes. So this is my sixth reInvent, and it amazes me how much innovation comes out this week. And it's just the amount of, the growth in this conference and the growth in our products over the years. Again, this is Amazon EC2. And if you watched the keynote this morning, you probably heard Adam in the keynote talk a lot about reinventing storage, reinventing chips, reinventing cloud. If you think about cloud computing itself, it really was a reinvention of compute and the way that customers utilized compute. Before, maybe a lot of you had data centers in your buildings where you had to procure and configure and set up compute yourself. Cloud computing really is a reimagining of how compute can be used. Now customers can just access compute via web services and get on-demand access to it at a low cost. So before I go into what's new with Amazon EC2, I always like to take a step back and think about where we came from. This is a snapshot of the blog when we launched our very first EC2 instance back in August of 2006. This is the blog from our chief evangelist, Jeff Barr, from his poolside in Cabo San Lucas, where we launched what's now called the M1.small. Back then, this was a really innovative instance. It was a 1.7 gigahertz processor with 1.75 gigabytes of RAM. It doesn't sound like much now, but really, it was really amazing back then. And back then, customers paid 10 cents per clock hour to use this thing. Now, when we built Amazon EC2, we thought customers would want three things, right? They would want to access compute on demand so they could spin up and spin down compute resources as they needed. They wanted to pay for only what they used, and they would only need one instance. Well, we were certainly wrong about that last point. From that very first instance that we launched, we have certainly grown. Today, we have launched over 30 billion instances. That equates to over 100 million instances launched every single day. That speaks wonders about not just the innovation in our EC2 platform and technology, but also our operational excellence in the amount of work that it requires to be able to scale this seamlessly. It took us about 2.5 years to reach the 1 millionth instance being launched, and now we launch over 100 million instances every day. Just tremendous growth over time. So instance is one thing, but really, when you think about Amazon EC2, people think about the reliability, security, and availability of it. And when I talk about availability, it's really about our global availability, right? 32 regions with more coming soon. And when we think about our regions, it's not just one data center in a single country. It's really every region has at least 3 availability zones, and each availability zone has multiple data centers associated with it. These data centers and these availability zones are miles apart. They have redundancy in power and water and networking and connectivity so that if anything goes wrong, your applications and your business doesn't go down, right? So if you had a region or availability zone all in the same building and there was an earthquake, for some companies that would mean that that region would go down. For us, it doesn't, because we have our data centers planned out and mapped out miles apart with this redundancy built in. And then it's not just about regions, but we also, through talking to customers, we understood the need of customers. We understand we don't have regions everywhere. So in certain cases where workloads need to be closer to the actual data center for latency reasons, or customers just want a faster access to the actual infrastructure. We also have something called local zones, and since our launch, we have offered 35 local zones, and we continue to add more and more local zones with each passing year. So from the very beginning, we had two big principles, right? The first was to provide customers with the tools and services to securely and reliably run virtually any workload. And the second was to innovate continuously to increase performance while lowering overall cost. We've kept those two principles over the years, and today, from that very first M1.small instance I talked about, we have over 750 instance types for virtually every workload, and we're going to go into some of these instance types throughout the presentation. But 750, just think about that. That's quite a bit. Now, you might think, 750, that's a lot. How do I choose, or how do I know which instance is right for me? Well, there's a couple ways. Let me first talk about the nomenclature of how to understand the instances, right? Each instance has varying ratios of compute and memory and storage and network. The first two letters, or in this example, M5 stands for the instance family. 5 is just the 5th generation of the general purpose instance family. The small letter after the first two letters is the processors. So in this case, this is an Intel processor, but we also have processors from AMD and our own Graviton processors as well. And then the last letter is the option, whether it's something like local attached storage, or enhanced networking, or faster EBS. And then finally, last is what we call the t-shirt size. So as I said before, our instances are offered in different ratios. So if it's an M5.small, that's a 4:1 memory to vCPU ratio. So in X large, it's just a scaling of that 4:1 ratio. Now, Art later will talk about a new service that we had offered, part of our Q family, that would help you pick the instance based on questions that you ask the system, like perhaps what is the best instance for HPC workloads or something like that. We also have another service called Compute Optimizer that uses your historical usage to help identify and help you optimize what instances are best for you. But we'll save that for Art. So part of our success over the years is not just our innovation, but our innovation with our partners. I want to invite Art on stage to talk a little bit about that.
All right, thanks, Martin. And once again, thanks everybody for joining us here today. So on this slide, I just want to cover that Amazon is the only company, the only cloud provider that actually offers all of these chip partners here. So we have x86, and that comprises our instances from Intel and AMD. We have ARM-based instances that are designed here by Amazon, and I'll talk a little bit about those. Those are our Graviton family of compute instances. And finally, we have Mac instances, which are also ARM-based instances actually as well. And I'll talk a little bit about what we've offered in the Mac space as well. And then thanks, Martin, for the teaser. We'll get to a little bit. I'll try to do a little demo of some of the features that were launched this morning later on in this presentation. But let's start with our Intel-based instances and what we've been doing in that space. I think one of the things that we talked about, a lot of us have heard, I'll say Gen AI first here today. We talked a lot about Gen AI stuff, but we're going to focus here initially on compute and what we have offered and what we can offer. So Intel has been a partner since we launched Amazon EC2 back in 2006, so 17 years of partnership. And as a matter of fact, of those 750 instances that Martin talked about, a full 400 of those instances are Intel-based. And the image that everyone is taking a picture of right now is the latest set of processors that we have on the Intel side here. I've particularly focused, if you look at the right-hand side of the screen here, on the 7th generation processors. Our 7th generation Intel processors are based upon Intel's Sapphire Rapids or 4th generation Xeon-based processors. These are actually custom to AWS, and the performance on these processors is roughly 15% better than you can get on any other cloud process provider running Sapphire Rapids at this time. So this is the beginning of my discussion about that 7th generation here. And let me give you a quick customer example. This came into me just a couple weeks here prior to reInvent. So this is from Tufts Medicine. They started migrating over from the 6th generation instances here, and excuse me, from the 5th generation instances, so M5N actually, over to the 7th generation here. They've been able to, because of the performance here available on the 7th generation instances, they've been able to increase the amount of density that they used per instance by over 68%. That additional 68% has resulted in a savings, an annual projected savings of about $1.2 million simply by migrating from that 5th generation over to the current 7th generation instances. So I think it's a great example of how migrating from one family, an earlier generation, to the current generation can result in additional cost savings for you. Here is within the x86 family. I'm going to explore a couple of the unique instances that we launched within the 7th generation family here first. So we all launched a unique 7th generation instance called our Flex instance. Excuse me, the Flex instances have been enabled by our AWS Nitro system, something I'm going to define and talk to you all a little bit about as we get down toward later in the discussion here. But the Flex instances is probably one of the easiest ways to get started using these 7th generation instances without trading off on performance. And these instances offer 19% more price per performance than our M6i generation. So moving from M6i to upgrading to the Flex instances will give you 19% better performance. Excuse me. And some of our top customers have already migrated to the Flex instances. Now, excuse me, also within the 7th generation family, and announced actually on Sunday this week, is one of our most recent previews here. This is also off of Sapphire Rapids. This is our U7i instance family. The U7i instances use the 4th generation Intel Xeon processor using Sapphire Rapids, and they're based for scaling up in databases, so large databases in the high memory instance size. Thank you. And if we look at that, these instances offer up to 32 terabytes, so 30% more memory than our existing U1. So U1 is the current family, and U7i is what we're going to. Just to, we changed the naming between the original U launch here. But what this instance has, in addition to 32 terabytes of memory, we also have increased the amount of EBS bandwidth by 2.5 times to 100 gigabits per second. And this instance supports IO2 Block Express. And it is going to receive over 125% better performance than the prior U1 generation. So I encourage anybody who has large memory workloads to take a look at the U7i preview that's now launched and is out there. So this isn't the only part of our portfolio. So I've talked here a little bit about our first x86 provider. Let me talk a little bit more about our AMD instances. So AMD, we started our work with AMD in 2018, and AWS was the first major cloud provider to offer AMD-based instances. Within the last 2 years, we've offered 2 updated generations of instances. In 2022, when Martin and I were here, I was talking about the Milan-based instances in the 6th generation family. And this year, I'm proud to announce that we have launched a 7th generation in Genoa. If you actually take a look and compare the M6A instances over to the 7th generation family, there's an incredible performance improvement that's out there. But I'll just call a mind here to the current generations that are out here. We have a complete portfolio on the AMD side, which includes a GPU-based instance, which is the G4AD instance. We have a high-performance compute instance, and we'll talk about that high-performance compute a little bit later. Martin will give us some information about that, and the full M, C, and R family on the 7th generation side. So a little bit more about that 7th generation family, specifically the M instances here. These are Genoa-based for those who have followed some of the AMD work. And going from that M6A to an M7A, delivers a full 50% more performance. So within going from 2022 to 2023, we offered 50% more performance here for these instances. Our CM&R instances offer twice as much memory bandwidth in the 7th generation as we did on the 6th generation as well. And they offer better performance than comparable AMD instances in the cloud. So I talked here about our x86 portfolio first. I'd like to talk a little bit about our ARM-based portfolio, starting with our Graviton-based instances. We've now launched, so in 2018, we launched our first Graviton-based instance. And since then, we've actually launched 4 generations. Well, I'm getting ahead of myself here, because the 4th generation was announced this morning by Adam, and I'll talk a little bit about that 4th generation as we talk here. These are pictures of that 1st through 4th generation here, only because I'm a chip guy and I couldn't resist having pictures of chips on a slide somewhere. Those are the real chips. First, we launched Graviton 2 that's out there. This was in 2020. Our 2020 Graviton 2 instances delivered 40% better price per performance versus the prior instances. Today, there are over 12 different Graviton instances based off of that Graviton 2 family. And there's today more than 50,000 AWS customers that are using Graviton. So what represents our current Graviton family? We launched our Graviton 3 processors, which is also a full complemented Graviton family here. You see on the right side the CM&R instances, comparable to the CM&R instances I talked about on the Intel side. This is the 7th generation, so Graviton 3 corresponds to that 7th generation of instances as well. And of our customer base, 100 out of our top 100 customers leverage Graviton, and over 50,000 customers are using Graviton on a daily basis. A lot of people, though, ask Martin and I, okay, so Graviton is a different architecture than the x86. Maybe I have x86 in my data center. Maybe I'm interested in saving something and migrating over. I'd like some assistance, maybe. Exactly what do you support? So on the left-hand side of this screen, we have a full complement of the Linux operating systems that are supported here, everything from Ubuntu to Amazon Linux as well, all of the latest generations. In the center here, we make it easy. We support most of containers-based applications, including for those of you who are interested in using a serverless solution, you can use one of our more managed solutions here. We have the AKS or ECS. And then finally, we've integrated this with many of our services here at Amazon. And the other thing is, 4 or 5 years ago, if I got on this stage and talked about efficiency, I talked to you about the efficiency and how good I am at designing architectures on CPUs and stuff like that. But since then, everyone is also concerned about power, sustainability. A lot of us and companies have sustainability goals. One amazing thing about the architecture of Graviton is it is able to use 60% less energy than that prior generation. And that is derived from efficient architecture of the system. Now, customers such as Zendesk have actually used AWS Graviton, and they've seen a 50% reduction in their monthly carbon emissions. Now, one other thing about efficiency of architecture design, I'm going to talk a little bit about efficiency. Efficiency also derives performance as well. And my efficiently using the architecture that I have allows me to deliver better performance for customers. And that's one of the things that we deliver here with our Graviton-based architecture. The other thing is efficiency also shows up in the design on the data center side. Dave Brown, who is the vice president of compute and networking at Amazon, always says to me the best type of energy is energy that you didn't actually use. And that means, energy and power to power the data center as well from a sustainability perspective. So that's one of the things that we've been able to do with the architecting here on Graviton. So one other important thing, I don't know if anybody out there has used or leverages SAP or SAP HANA database, but earlier this month, SAP announced that their HANA database is running on AWS Graviton 3. SAP, has seen a 30% better compute performance and 50% higher memory using this. And by choosing to run SAP HANA in the cloud, they are seeing a 45% reduction toward their carbon footprint. So really impressive here with the reduction in that, but also the performance. And just on a personal note, a lot of people who use SAP HANA had asked me questions about it. Can I use it on Graviton? So I think that now that SAP is directly running it here, I think it's a great positioning for anybody who's interested in running SAP HANA here. So just announced this morning was Graviton 4. Graviton 4 is our most powerful and energy-efficient chip that we have built thus far. And when it comes to silicon design, we have found ourselves taking a unique approach that I characterized earlier. One of the things, so what does Graviton 4 deliver here? So we offer up to 50% more cores than the prior generation. Graviton 4 is also the first processor that we have built that handles multi-socket coherency, and it can scale our instances up to three times more CPU, and 3 times more memory than our prior generation. So that can deliver for high-performance databases, memory cache, and big analytic databases that can be used here. And that's not all. With Graviton 4, we've also heard everyone has questions about security. So to validate real-world workloads, we're also trying to raise the bar on security by validating, monitoring, and protecting every stage of our host boot process. I'll talk more about how the Nitro system helps with security and delivers a secure message to everyone, but this is validating what feedback that we have heard from customers. We have fully encrypted the high-speed hardware of Graviton instances here with Graviton 4. Also announced this morning was the preview for our 8th generation. This is our first 8th generation instance, and I encourage everyone to take a look at R8G. R8G is a memory-optimized instance, so our M is general purpose, R is memory optimized, and C is compute optimized. So we're starting off the Graviton family here, this time with the R8G. We get over 30% better compute performance compared to the R7G family, and I mentioned some of the other statistics that are here. So sign up for the preview. You can actually just Google Graviton 4 or R8G, and the preview link will pop up. I did it before the meeting, before here, so I know it works. Otherwise, I was going to put a QR code in here. But finally, our last ARM-based instances are Mac instances. With over 34 million developers that are out there, Mac is a large community of people that are using it. We have been one of the first, we are the only cloud provider actually to offer Mac instances. And this year, we expanded that to offer the Mac 2 Mini and the Mac 2 Pro Mini. These have provided a more than 35% faster performance compared with our M1 Mac instances that were launched prior. Customers are now able to achieve faster build times without having to install or manage that infrastructure here. Here are a sampling of some of the customers that are out there. So customers such as Pinterest, Goldman Sachs, Riot Games, all probably familiar names to those of you in this room here. They've achieved up to a 4x improvement in performance by migrating their instances to the cloud, and an over 3x increase in parallel workloads. And it has resulted in up to 80% reduction in build failures simply by using the M instances here in the cloud. So it saves a lot of resources and time. These aren't the only instances that we're talking about here. I'm going to turn it back to Martin to talk about some of these higher performance workloads that are out there. Martin?
Thanks, Art. Whereas a lot of the computing instances that Art mentioned are more for generalized computing instances, there's another class of instances called high-scale instances. And some of these high-scale instances are some of the ones that were the most difficult to bring to the cloud. Workloads like HPC, some customers thought would never come to the cloud because it's so high, it requires such high-performing infrastructure. If you've heard of HPC, it's really all around us. It's used every day from things like computational fluid dynamics, to drug discovery, to genomics, to electronic design automation. It really is part of all of our lives, even if you haven't heard of it. And we have an entire portfolio of EC2 instances, again, from our partners AMD and Intel, as well as our own Graviton-based instances. Art had mentioned the 7th generation instances earlier, and this is really just a continuation of that 7th generation instances. We have worked on these instances over the years, and really we've optimized them for the different types of HPC workloads out there, whether it's compute-intensive workloads or memory-intensive workloads or data-intensive HPC workloads. And our work has been truly recognized. We've, over the years, won several awards and been recognized by HPC Wire. This year, again, for the 6th year running, we were recognized as the best HPC platform. In addition to that, we've won several other awards for specific use cases and customer choice awards as well. So really proud of our HPC portfolio. Another high-scale workload you might have heard of this year is generative AI. Now, you've heard a lot about generative AI this morning for sure, but more and more companies are using generative AI and machine learning to really change the way the business operates, to make their employees more productive, to provide better customer experiences, and to really optimize what they're doing. Now, when we think about generative AI and machine learning, there's really two types of workloads that we focus on here. The first is training, which is the type of workload where you're building and refining your model. And then the second type of workload is inference, which is actually deploying those models and putting it in production. I'll talk a little bit more about this. So we have a portfolio for training as well as inference. We partner with many partners from NVIDIA for our GPU-based instances, Intel, Habana Gaudi for training as well. We recently announced a partnership with Qualcomm as well to bring their AI accelerators to the cloud. But we also build our own chips, Trainium and Inferentia, that I'll talk about in a bit. But first, let me talk about talk about NVIDIA. You know, machine learning and generative AI has seen tremendous growth over the years. If you look back to about a decade ago, models were relatively small. For example, in 2013, towards 2012, the model size was about 60 million parameters. That might seem big, but to today's standards, compared to today's standards, that's relatively small. And you didn't actually need that much compute to handle those model sizes. In fact, you could get by with only 2 GPUs. Today, however, model sizes have grown orders of magnitude, and today we're seeing models in the hundreds of billions, if not trillions of parameters in size, and customers are wanting clusters of up to tens of thousands of GPUs. So we've worked closely with NVIDIA over the years to develop a whole portfolio of GPU-based instances. The most recent one that we delivered earlier this year was Amazon EC2 P5 instances. Now, these instances are really powerful. They're based off of their H100 GPUs, which at the time was the most powerful GPUs out there. They are powered by 8 NVIDIA H100 Tensor Core processors with up to 4x higher performance and 40% lower cost over previous generation. They're highly scalable, right? You can scale them up to 20,000 GPUs with our ultra cluster technology, which results to 20 exaflops of aggregate compute performance. That is just amazing. That's really like a supercomputer in the cloud. In addition to that, we link everything together with our EFA network to give it really fast 3,200 gigabit per second high-speed networking. So really amazing there. But this is just one example. You might have heard this morning that we are deepening our partnership with NVIDIA and really delivering, making AWS the best place to run GPUs. So part of the announcement, the deepened partnership this morning when Jensen came on stage, and Jensen Huang, CEO and founder of NVIDIA, came on stage, we are announcing more GPUs and newer NVIDIA technologies coming to the AWS cloud. This includes the L4, the L40S, and the H200 GPUs that will really help with advanced graphics, video, and AI, ML, and generative AI workloads. But we're also working on building the first cluster with the GH200, which is their Grace Hopper architecture. No cloud provider has done this yet. If you're not familiar, Grace Hopper is a combination. It's really a super chip. It combines Grace, which is NVIDIA's ARM-based CPU architecture, with their Hopper GPU architecture. So it's really a super chip, and we're working to bring that to AWS to really give our customers a super powerful cluster. But beyond that, we are also bringing DGX Cloud to AWS. And we're working with NVIDIA to build what we call Project SIBA, which is going to be the world's largest and fastest AI GPU-based supercomputer that will really help customers, including NVIDIA themselves, build and train their models and run experiments in the cloud. So really exciting announcement this morning. And those are all coming in 2024. So we look forward to delivering those and seeing what our customers, as well as NVIDIA, can do with that. So really exciting there. Now, GPUs are super powerful and they're super popular, but they're really hard to get in the sense that because everyone wants to do AI, ML, generative AI, they're grabbing as many, they're trying to acquire as many GPUs as possible. And this is true even when they don't need it all the time, right? So for example, if you were going to need GPUs for a month, but then you might be worried that you're not going to get access to it, you might just grab it for all the times, even when you're not using it. Earlier this year, actually just a couple weeks ago, we announced a new service called Amazon EC2 capacity blocks for ML. And this is basically a reservation systems that help customers get access to GPU instances. The usage is very straightforward. It's very much like when you book a hotel or a rental car. You just have to specify the start date that you need those GPUs, the duration of how long you need those GPUs, and the amount of capacity that you need. And it really provides customers with reliable and predictable access to their GPUs so that they can run these short duration GPU training and experiments when they need it. And that predictability really helps our customers and really helps us democratize access to these GPUs. Again, here, just an example. If you needed GPUs starting on December 11th, and you needed it for a 5-day duration, you would specify start on December 11th for 5 days, and then the amount of GPUs that you need. So really simple and straightforward, and so far we've heard great feedback from our customers, and the ability to get GPUs really is going to change how customers approach AI ML. But given the growth in machine learning that I talked about, GPUs are powerful. But customers always want more, and they're also looking at cost. With the size and complexities of AI ML models and generative AI models growing orders of magnitude, the cost of compute is actually increasing as well. So earlier this year, we announced our Trainium platform, AWS Trainium and TRN1 and TRN1N. These are these provide customers with lower training costs, up to 50% cost to train savings. They are deployed in ultra clusters, so you can deploy them in up to 64,000 clusters of 64,000 Trainium chips. And they offer up to 1,600 gigabit per second of EFA version 2 networking bandwidth for really fast communication together. And they're supported by the most popular machine learning frameworks out there, including things like PyTorch and TensorFlow, and coming soon, JAX. So those support of those popular frameworks really help customers get started quickly and easily. But of course, we didn't stop there. This morning, we also announced Trainium 2 coming soon. These are our second generation purpose-built chips for generative AI and ML training. And these are even more performant than our first generation one, 4x faster than Trainium 1. They are going to be deployed in even larger size ultra clusters of up to 100,000 Trainium 2 chips. And they're really ideal for really large scale generative AI models with hundreds of billions of parameters in size. So again, really for those larger models and when you need that super performance. And of course, just like our Trainium chips, they're supported by the most popular AI ML frameworks out there. Now, a lot of the attention today is focused around training because we're really at the start of machine learning and generative AI, where customers are trying to build the best models out there. But once the models are built and they're at scale, most of the cost is really going to be around inference. Now, if you think about an application like Alexa, for example, right? We train the model for Alexa periodically throughout the year. But think about how many inferences, how many times are you asking Alexa a question like, how's the weather? What time is it? Play my favorite song. We're literally getting millions, if not hundreds of millions of inferences to Alexa every single day. So the cost of inference in the long term is going to outweigh the cost of training. So that's why our first chip we built was Inferentia 1. And earlier this year, we announced the second generation of Inferentia, which is Inferentia 2. Now, these are super powerful, high performance, energy efficient, and low cost inference chips with up to 384 gigabytes of memory, of high bandwidth, high speed accelerated memory, 4x higher throughput, and 10x lower latency than our previous generation Inf1 instances, and really, again, optimized for large models, 100 billion plus parameter models at scale. Now, chips and processors are one thing, but then it's really, when we think about EC2 and we think about what's made cloud computing popular, it's really about the whole system. In addition to the processors and the instances, I'm going to bring Art back on stage, and he's going to talk about Nitro and the underlying infrastructure. Art?
All right, thanks, Mark. Presentation, we talked about the 750 instances that exist, that being a lot of instances. But one of the core capabilities that have enabled us to do this is the development of our Nitro system. Back in 2012, 2013, we started realizing that how a lot of other companies in the cloud space work here is we have to do some management in order to parcel out and sell CPUs out to everyone. But we started realizing that management function was becoming increasingly more consuming. And that management function was resultant in that fully 25% of our capacity was being used by us to manage the software. So we needed to figure out a way to re-architect our entire system here in order to give better performance in the cloud. So we introduced the AWS Nitro system back in 2017, 2018. And it is the foundation of our modern EC2 instances. And I used to come here with a little bit of chart, and you could see once we started launching in 2017, you can see this massive increase in the total number of instances that we're able to launch. The reason we're able to do that is we've now officially separated our management function away from the CPU, away from the hardware function. And this is across the board. This has enabled us to launch more instances faster, and it also has enabled us to actually develop a system that provides even better security throughout our entire architecture. So the system is comprised of a Nitro card here, which has a series of chips on it, a Nitro chip, and a thin hypervisor that's on top. And then inside that, a security chip that makes sure that when we boot up and anything is happening, that we verify the hardware and the software. No AWS employee has access to data that's out there that's part of this architecture. But what this also does, it allows us to do a lot of behind-the-scenes work to do upgrades to the system without impacting customers, and it reduces the management function. So fully today, we actually, if you take a look at our instances, we sell 100% of that CPU to the customer, and you get near bare metal performance. It is the Nitro system that has enabled that as well. So what have we done since we started here? it's hard to believe, but within our networking bandwidth here, back in 2006, we offered a stunning 1 gigabit per second in network bandwidth. Now, I assure you, in 2006, if we were all sitting in this room, although I could have fit all of our customers in just this one room, we can't do that any longer today, that 1 gigabit per second was literally state of the art. Today, we look back and kind of chuckle about it, but since then, we've now offered up to 3,200 gigabits per second where needed here. That's the type of performance, though, that's absolutely required. And Martin talked about the Trainium 2 instances here. We are now offering up to 6,400 gigabits per second in that networking bandwidth here. So these numbers are, we're not just adding more networking because we have nothing else to do on a Thursday afternoon, but we're adding this because this is the demand that customers are supplying. And this is, you can see the arc of what's happening. And I had to do this kind of build here, otherwise the 1 gigabit on the far left looked even obnoxiously smaller as well. So just to make sure that we can see kind of what has happened here and what's happening with compute as well. So not only this, we're talking about network first, but also the other thing many of you customers are likely really interested in is access to storage as well. So we've also changed the amount of memory, the amount of bandwidth that we have here to EBS, for our EBS. And we've seen a great deal of interest in more performance here in our elastic block store. So in order to meet that demand, we now offer up to 100 gigabits per second with 400,000 IOPS here, and that's across the board. So I mentioned memory here, and I want to kind of close a little bit some of the Nitro system here by talking about the final piece of silicon, if you will. I don't know that memory is necessarily, everybody thinks about it as silicon, but we develop our own SSDs here, solid state drives here at Amazon. Why? Because the performance of these, knowing our own cloud-based system, we're designing something here specific to the cloud. And one of the things we decided when we were doing this is that customers are really concerned about latency, and latency in accessing memory. And there's two types of latency. There's just general latency and tail latency, which is the variability within that latency that happens there. So one of our goals here was to introduce these SSDs here to provide the best possible experience. And latency and access to the memory translate into performance issues for customers, because the longer it takes to get something from memory to be able to act on it in the CPU, the longer it takes you to do and accomplish a task. So these SSDs that we introduced offer 60% better latency, and we've also reduced that tail latency, or the variability within the latency, to create more predictable outcomes by 75%. So those are all part of that Nitro system. But that's not all the Nitro system affords. I alluded to some of the security elements that are here, and I want to just briefly talk about that security element is here that we finished. It's enhanced security that we've delivered. So when we launched in 2017, as I said, we restricted all operator access to data. So that means that no employee, not Martin, not myself, not anyone else you'll meet here, can actually take a look at any data that's ever been exposed within the system. No AWS has that access. This also offers us the ability to securely patch and modify the system without having any impact to customers by doing this offline. And the other thing is we are so committed to this, we have no SSH access, so there's no purpose access of any kind to the system at all here. And we have no APIs that are provided to access this data. And it's something, by the way, I might mention that we also have included in our terms and conditions, the small font, tiny font that you probably read and click accept, or hopefully you accept when you start to use it. We have actually now included this information as part of those terms and service, that this is something that we sign up to model when you work with AWS. So the other thing is a lot of times customers have a need for additional security. We developed something, excuse me, called Nitro Enclaves. So imagine a situation where you're at work and there's employees who need to access for perhaps personally identifiable or PII type information. But this type of information is on a need-to-know basis, pretty much. And certain employees, let's say I go to my local bank and I go up to the teller. that teller may need to have access to my bank account information and to the balance that's in that bank. But another employee of that bank may have an interest in knowing the total aggregate amount of money that is being stored at the bank, but they shouldn't have access to my bank account and my bank information. So they have an interest in the total data, but they don't have the rights to the specific data about Art Baudo. And in that type of instance, you can protect that personally identifiable information so that somebody can get access to that resultant product, and only the right people can see or have access to the private information that's there. That's one of the reasons that we have developed and we had launched Nitro Enclaves here as well. So back to my security element as I close out this section here, is that this QR code here includes a link to the full report. We were so convinced of this, we actually went with a third-party cybersecurity company called the NCC Group that did an evaluation of our architecture to certify that it is indeed no operator has access to any of this information. And so you can take a look at that. And then the other thing that I want to mention, we are trying to be even more transparent about our architecture and about the security elements. So you can also look up our white paper on the Nitro system security if you're so inclined, and it's available, publicly available as well off our site. So I want to conclude today, though, by talking about something that I think is really fun, is some of our AI-generated features in the natural language processing space. Oh, we talked about those 750 instances earlier, and how can I make it even easier for you to select those instances? So we are using generative AI here, using Amazon Q, which can help you select additional your instances and instance type. I'm including an example here that I ran actually last week when I was setting this up here. So I typed in this query using natural language processing. And the reason I type something this specific is because I want to get a specific answer out. But I want to show you how you can make use of this system to help select or define instances. So here's my question. I want to deploy a large database on a web app getting high performance. Okay, so it's going to think here for a second about it and give me some result. I don't plan to read this entire thing to all of you, but what it has done here is it provided me a series of answers. It's actually even ordered them based upon the criteria that I've typed in. So the first here is what it thinks is the most recommended. I put in high performance as one of the key things. I put in database. So the first thing it did was recommend the latest AMD 7th generation R7A instances. But maybe there were some other qualifiers that I didn't include in my question. I mean, all of us have done that when communicating with a chatbot here. So I typed in an additional question here to say, what if I wanted them to be Intel-based instead? What is the response then? So here, it provides a more detailed response. Thanks for a second. And provided a response. It looks like I went forward here to my next question. I also offered a question here on video encoding as well, to just take a look at a completely different workload, also including a video encoding with high performance workload that I wanted to include. Same thing here, it'll provide a response back, and it provides 3 responses. And also the blurb at the bottom is a description about why it chose that response, and it chose that based upon that information that you provided. I like to use that blurb myself to say, okay, do I need more information? Do I need to ask it another question? In this case, I also asked a secondary question here. What instant choices provide better availability? Martin mentioned, some availability things with GPUs, particularly in this video space. So I thought that this might be kind of a great response to, or a great question to ask it. So it now provides some information in a textual format here on that. And the final AI feature that I want to talk about today is called console to code. So a lot of people use the Amazon console for prototyping purposes. And think about a situation where you come to this meeting and you listen to this discussion here, and you probably think in the back of your mind, I will remember this in about 2 hours from now. There's certain aspects of it, like what did Art say? Like I have to revisit that presentation or something like that. Well, a lot of customers go into the console, perform a task, and later on realize, okay, this was successful. I want to duplicate this next time I come in to the console. I want to get a start. So one of the things we've done using our well-architected framework is we have launched a way to actually go into the console to generate code so that you can take the work that you did prototyping and actually have a snippet of code to be able to replicate that later on and use that as a start as you go to do production-based models. So these are some screenshots that I took earlier today of the console itself. If you look on the left-hand side there, you can see console to code. You can just simply click on that here. And you can see, though, in the center, for those of you familiar with the console, you can see recorded actions here or in the center. So these are the actions that it's been recording that you've been taking. In this case, I chose the first two actions. You can see them lower highlighted here. And you'll be able to select on them. And then on the upper right-hand side, you can choose to select the type of code that you might want to generate. In this case, I have TypeScript code, but you can also choose Python or Java. Dave Brown did an example earlier today with Python, and so Adam also did the example with Python. But I chose TypeScript code because it actually is the most popular that developers using the console tend to use. So after you select that, it will actually generate the TypeScript code for you and show it here in the screen, and you can download that as a developer for usage later. The goal here is to take work that you did in the console and exploratory work that you did and be able to use that later on so that you don't forget it. This isn't geared as production-based code, but as a starting point for you. So I realize that today, Martin and I have covered a lot of ground here with the Amazon EC2 instances. We started off talking about the x86, the Graviton instances, the Mac instances. We talked a little bit about HPC instances. And here we've ended with some of these examples of we've had some of the newest features using generative AI in addition. We are not finished innovating here at Amazon. And next year, if you show up here again, we're going to have even more innovations as well to take a look at. So I want to thank you all for coming here. And before I leave you, I have one final thing. If you enjoy taking a look and you enjoy learning about AWS, I encourage you to take a look at our new badge, Compute. This allows you the opportunity to learn a little bit more about compute while earning a free badge. And this is our new badge system that is free to take a look at. So this is can be part of your learning journey. And you can go to AWS Skill Builder and get a free badge. You can place the badge on your resume or on LinkedIn or whatnot that gets handed to you after you have taken some of this. This badge, excuse me. And there's some coursework there, so if you're not tired of hearing me speak, as well, you can watch some more videos of me as well and answer questions about it. I want to thank all of you for coming out to Vegas and joining us here today. Please don't forget to take the session survey. We really do review all of the feedback that has been provided here. And I want to thank Martin for joining me and thank all